now we already print our report. That the people of that.
You, where's the report? You give it to. Okay, you give it to the report. Okay. Bun Wei. You have to submit the report, is it? You have to submit the report. You have to submit the report. But the Malay.
Wah, jalan. This guy jalan.
Yes.
Wow. You don't need batteries that way. Huh? You tell me what batteries.
Okay, next up we have Team Biming from Singapore Poly. Let's give them a hand.
Hello, testing. Rocket life.
Good morning, judges and lecturers. Today, our team is excited to present our design proposal for a co-working office at Coney Island. Our team consists of Alicia, Candice, Wilson and William, and myself, and Wei Jie, who is not here today. So before I begin, can I get a show of hands, or have anyone heard about the Storm Area 51 event on Facebook? I see a few hands behind that, yeah? Thank you. So, why am I asking this question is because if you look closely at our building perspective, it might look like a spaceship has just landed on Coney Island itself. But I assure that it is not a spaceship. So jokes aside, Singapore, the world is currently facing a digital disruption, and Singapore moves towards becoming a smart nation. And using Punggol Digital District as a starting point, our generation, the millennials, grew up in the age of the internet, where it seems impossible for us to disconnect from our devices. Our building design offers us a way to unplug and reconnect to people face to face. So now I'll cover through our building strategies. So first of all, we have our slanted roof. Why we decided on a slanted roof is because we wanted it to have a hill typology so that it blends in with the surroundings as compared to building towers. This also created an opportunity for us to collect stormwater at the lowest point of the building for flushing and irrigation systems of our building. And in the center, we opened an atrium so as to conserve the existing playground and allow natural daylight to penetrate the office through high volume spaces. And finally, we have our rooftop garden we planted with green native species so as to increase the biodiversity of the area and mitigate urban island heat effect. So with these strategies, people are able to unplug from their devices and reconnect back with people and nature. Now I'll pass my time to Candice.
Thank you, Sylvester. Sorry. Now I'll pass on to Wilson. I'm so sorry.
For us to achieve a high DFMA, right, we have to ensure that all our building components, right, like the structural, is made out of 3S, which is single, integrated, simplicity, and also single, integrated, and yeah, we have 3S. So sorry, I just like wake up. Okay, so actually, we ensure that all our building design, right, is of these three principles. So for instance, our precast beams and slabs and columns are all made of single ingredient, as you can see. So we also achieve that the modularity, right, is to every of the beam and slab is of 20 meter length. And also most of the connections is made out of cobalt or else bolts and nuts for the columns, and also like the slabs is where we actually, yeah, it will be completed right after the placements. Yeah. Okay, so to achieve DFMA, right, you can see that we actually break up into two parts. One of the section is at the other side, which is highlighted in blue. So we actually try to achieve the modularity whereby all the beam and slab, right, is spread across horizontally, that it is 20 meter. Yeah. Okay, so we also try to achieve a very accurate construction process. We need to have a Gantt chart. So as you can see at appendix page 13, we actually have a very detailed how Gantt chart it will take, and the construction process will actually completed in 247 work days and 6,400 hours for completion. Yes. Next. Okay, I will pass on my time to Candice.
Thank you, Wilson. So now I'll share with you our natural daylight. So the yellow ones indicates that there is 700 luminance, which is above the average range of indoor recommended lighting. And as you can see from the data, because it's quite small, so I will explain to you. So within 9 AM and 3 PM, the average of the passing for the lighting will be 75% for 9 AM and 3 PM will be 74%. So this is a favorable range which meets the basic needs of indoor recommended lighting requirement. And in Singapore, lighting design for workplace has to comply the Code of Practice of Singapore Standards 531 under the Workplace Safety Health Act, as well as it also coincides the BCA Green Scheme. Okay, this is cross ventilation for our building. So the yellow portion shows the ventilations, and so cross ventilations is have different types of inlets and outlets, and louvers can direct airflow in upwards and downwards. So to meet the lean and sustainability of the design, we maximize the passive design by implementing cross ventilation. So our workplace is is quite our workplace has a high ceiling, right? So yeah, sorry. So our workplace has a high ceiling. So we implemented like floor plates, like we raised the floor system, and we implemented air conditioning which flows from the floor. And NME services are also implemented, like under the raised floor system. So in addition, all our privatized office spaces are only have air conditions. Like the rest of the building is quite open. So this is to maximize the energy efficiency of the building. Next. In order to promote renewable energy, we implemented solar panel type of shelter and estimated it garners 140,000 kilowatt-hour per year. And we actually have calculated, so the blue portions are the solar panels area, which is 1,000 square meters. And after we calculated, we estimated that 13% of the electricity usage per year is based on the EMA data on commercial building of up to 155 kilowatt-hour per meter square per year electricity usage, with our GFA being 7,000 square meters. Next, I'll pass on to Alicia to share with you more about our facade. I'll be talking about the sun simulation. This sun simulation is done using Insight, which is a Revit plugin, and using this simulation, this has generated the design for the facade. So this is the facade design. It's created using Rhino and Grasshopper, and the facade was it is a stick system, curtain wall facade that is made out of terracotta fins and allows for natural cross ventilation to occur in the building. So these terracotta fins are computed for maximum shade from the sun. And the reason why we chose terracotta fins was because it is a renewable and lightweight material. And so moving on to the facade detailing, how we detailed the facade was the terracotta panels are supported by vertical aluminium posts, and then the aluminium posts are bolted to steel L plates that actually connect to the inverted T-beam of the structure. Moving on to the virtual reality shots. So the first would be the outdoor workshop VR space. This is the outdoor workshop VR space on the first level in the atrium space. So as you can see, it's surrounded by large greenery, and we have actually retained the existing playground of the site. Moving on to the rooftop garden, it is also surrounded by large greenery placed on the roof, and people, after work, people can come up here to enjoy the sunset. And I'll pass my time on to William.
Thank you, Alicia.
So sorry. So what is our unique about this project is that we adopted this photogrammetry method. So photogrammetry produces a 3D reality modeling in our on this Coney Island. So we actually, this is a 3D survey graded model, and to achieve a high survey graded model, right, it would need to be imported with GNSS survey grade, like the the GPS coordinates. So this could be come in useful to actually produce the volume where we can cut the volume in Revit, and also giving us architecture impression, and also monitoring the progress, and also ensuring that the future maintenance of it. So how do we ensure the future maintenance is that this photogrammetry can go up to a very high accuracy, which can be seen as real life, and you can monitor the site progress as well. So if there's time, I will share with you more about it because it's a FYP project. Yeah.
Thank You, sir? Now we're going through slightly because our team is made mostly from civil engineering, so we have this structural analysis. We started with RC concept in mind when the Archi was having their meshing design. We are thinking maybe if they come with the RC design, we should come with a simple VBA programming that can give us the load tagging analysis and also the structural analysis by scripting it. It doesn't take a lot of time, but it keeps a lot of things become convenient. After that, I think we have some development in the structure where one of the biggest challenges is the span length. Then there's one point of time we are changing our material to structural design, and then we have difficulty on that. And then it means we need to discard this VBA, so there's a structural development on that. After that, we also have some. Okay, I'll slightly just go through because we do not have much time left. Okay, because we design our model mostly using Revit, so we, especially the structural model, so we have instead we do not apply any module for PVC, but we have a precast component. So we try to generate the SOR using Revit itself, and then try to come down with the cost-wise the precast component for the precast component, sorry. Okay, we've done the class detection mainly for structural and architecture component. Okay, sure. We also propose a B score and C score with the green mark score. So after the model has been done, the B score is at 109, passing the minimum. C score is at 57. Green mark is at 74.55, which is platinum. These all we assess ourselves after we have finished the model. Yeah, and we actually.
I would like to show you our.
We'd like to show you our video. Sorry for the technical issue.